We're here for Spot's first active demonstration on Sellafield site. So Spot is here to replicate a survey done by our health physics team who would, on a routine basis, monitor the facilities here.
Spot's been carrying a LiDAR payload that builds up a full 3D picture of the surroundings that it's in. Once we have that 3D image, we can then start to actually apply the radiation source terms to it. So the robot has a number of different radiation sensors. So what we can build up is a 3D image that's colorized with where the radiation is physically located in this facility.
So being able to attach a device like what Createc has been able to develop and the software that they've put together associated with it to Spot has really brought about this incredible ability to autonomously create a map of a radioactive environment without a human being ever needing to step foot inside the facility.
It can use its cameras, its sensors to characterise the cells for us, which means we don't have to go in there, we don't have to do it, and keep the risks and hazards for an operator such as myself as low as reasonably practicable.
For me, it's a real opportunity that we can use Spot to support those operations and actually do a lot more of the routine activities, which then means the operators can do the more interesting sort of tasks that are needed to decommission the Sellafield site.
So the map that we created in here before, we can transfer that over to the autonomy side of things, and we can say effectively, I want you to go to this location and do this action, and the robot will wander off over there and it'll do said action. If the map changes, the robot can then navigate around, and it's not replaying a mission, it is actually doing autonomous navigation from point A to point B.
One of the key things that's actually made this project possible has been the collaboration. In terms of supply chain, there's ourselves at Createc. We're working very closely with UK AEA Race. Createc are providing the robotics and the payload expertise, and Race are providing the contamination control suite for the robot. And then we've worked very, very closely with Sellafield to understand the actual process of how we can bring the robot into the facility and also to safely get it out of facility and cleaned away.
When it comes to radiation, ionizing radiation eventually does have a negative effect upon electronics. So with the robot, we exposed it to fields that were extremely strong, up to around 500 rem per hour. And the robot absorbed a total dose of 413 rem. We were attempting to cause the robot to fail. The reality is the robot remained functional throughout. So at this point in time, we don't know what the upper ceiling is for what the robot can absorb for radiation. We're still attempting to determine what that is.
So because of the demonstrations that have been undertaken in an active environment so far on the site, and the trials that Boston Dynamics have undertaken in the States, it's proving that it can withstand a very high active radioactive environment, which is something that's going to be absolutely useful for our future challenges on the Sellafield site.